Hello, my name is Obi. I'm 2
All right. All right.
and that's enough.
Okay. All right, y'all. Thank you. Welcome back. Here we are for our last video that we're gonna make today. So, in the last video, we left off on this slide, and we were stating that these distributions are obviously skewed, and so we should be using the medians and the interquartile ranges to be comparing these. And so we left off here and just comparing the medians, and we were just saying, well, the middle shelf by far has the largest median, indicating that over half of their cereal boxes are going to have sugar amounts of 12 or more. So that should be our winner there. So previously, before this, we were doing means and standard deviations, and then there we should be careful because as you can see here and for the middle shelf, the average is much smaller than the median, right? So it may be the average may be hiding the true large number of high sugar contents in that shelf, right? And the opposite for bottom, right? The mean is much larger than the median. So this mean could be deceiving in the fact that we would think there's more boxes with a high number of sugar, with a larger number of sugar than compared to what there really is. So what we're going to do is we're going to bring it together with the interquartile range, and we're going to introduce the last topic in chapter 3, which is box plots. So the box plots uses pretty much all the pieces of information that we've been using in the range and interquartile range and the median to create very nice visuals. So the box plot here is a visual. So this is like a horizontal box plot. Typically they're also vertical box plots, which you'll see in StatCrunch. Okay, but they usually always follow a number line. Either the number line is here, so here this is shoe size from 1 to 14, or it could be vertical as well, which we'll see that in StatCrunch. But how we make this box plot, is really quite simple, but mainly it's composed of a box, and in this box is about 50% of our observations. And then outside of the box, these are called like whiskers. Usually they're called like whiskers. And so usually between these two numbers here, there's 25% of the observations, and between here, there's 25% of the observations. Okay, so a box plot provides a really nice way into describing the distribution, because it divides it into forts. And it's also very useful in comparing a lot of multiple distributions with each other. Okay, so in this example here, the median shoe size is 8. So that's saying 50% of shoe sizes are above 8, 52% of the shoe sizes are below 8. Okay, and so the first edge of this box, okay, the first wall of this box is located at the first quartile. So the first quartile is at 4. Okay, so that's where we draw this line here for the box, okay, the first edge of the box. And what this quartile is saying is that, well, 25% of the shoe sizes are below 4, and the other 75 are above 4. All right, so we draw this line over here, and we draw this line over here until we stop. Okay, we stop at the third quartile. Okay, so the third quartile for this example is 10. So we don't have the data here. Okay, we don't have the data. We're just given these already. Okay, but we haven't seen the data. But either way, this is the third quartile. So what it's telling you is that 25% of the shoe size are from here to here, and 75% are from here to here. Right, and then here, this 13 is the largest value or the maximum, and this value here, which is a 13. And this indicates, I don't know, I guess this is 1.5, which is the smallest value or the minimum value. So from the smallest value to the first quartile, there's 25% of shoe sizes fell in here. From the first quartile to the median, 25% of the shoe sizes fell between here. And then from the median to the third quartile, another 25% of shoes fell in here. Okay, so there's a lot. So it's kind of telling you this kind of shorter. See, this is kind of a bigger rectangle, and this is just like a square. So what this is telling you is that there was a lot of shoe sizes between 8 and 10 for this example, just a lot of them, right? There's 25%. Well, there's 25% within a short range, okay, from 8 to 10. Okay, and then there's another 25% of shoe sizes that range from 10 to 14. Okay, so this box here is kind of the length of this box is the interquartile range. Okay, and the middle 50% of data is in this box here. Okay, is in this box. Okay, all right. So just note that in technology and also looking out for these things, you know, when we had the empirical rule, we were saying, okay, well, the empirical rule gives us typical observations, but also unusual or weird observations. And with the single value, we can use a z-score, and if the z-score value was larger than 2 or less than -2, we consider those outliers. Well, when we're dealing with the median case, we have another way of determining whether a value is an outlier. So when you do box plots in StatCrunch or other software, you may get these dots out here as well. Okay, you may get these dots out here. Okay, so really, I mean, really, this is like the true maximum value. Okay, but the thing is that it was an outlier, right? So the maximum value is going to stop right here. Okay, so this maximum will be either the next value that's up, or it could be up to the third quartile plus 1.5 times the interquartile range. Okay, and as far as this minimum value here, see, this is maybe the smallest, but it turned out that it was an outlier, right? It was a weird value, right? So it wasn't counted as a minimum, it was counted as an outlier, and this value here was counted as the minimum. Okay, so pretty much if there's a value that's smaller than the first quartile minus 1.5 the interquartile range, we're going to consider that an outlier. Okay, so we'll see these dots here, and that's how you determine whether. So it's kind of similar to the z-score, because we're looking at it in terms of standard deviations away, right, from the center, and then here we're doing this kind of one interquartile ranges away from the center. Okay, so that's where we're getting these values from. Okay, so so whiskers in a plot are not potential outliers, but potential outliers are points that are more than 1.5 interquartile ranges below Q1 or above Q3. Okay, and the only reason they do 1.5 here is because, you know, we pretty much have a half and a half already here. Okay, so these are the vertical box plots here that we'll see, and you see how it's very easy to compare multiple distributions. So here they have 3 groups of plants. One was given grow fast fertilizer, one wasn't given any fertilizer, and one was given the super plant fertilizer. And what we recorded for each plant was the height that they grew, right? So obviously, I mean, it appears that this graph here, right, this graph here is shifted up the most. So see, the number line is on this axis here. So by this box plot here, we're saying, well, 50% of the heights were between, you know, roughly 22 and 29, right? Whereas here, 50% of the heights were between 15 and 22, right? So this is just shifted completely above, right? So it's very easy to distinguish that this grow fast fertilizer is the most effective in growing taller plants. Okay, so very nifty use here, and a very nice visual. And this is kind of the if we're using the median interquartile range, I mean, the box plots are a good way to combine all the information together and comparing the groups or examining the distribution. Okay, so now what I want to show you is how we do this in StatCrunch. So going back to that cereal box example, go here. So let me create some Boxplots graphs. So let me do a graph. So last time we did, remember, the dot plot for each one. But now let's do a box plot. So I'm going to do a box plot, and I'm going to look at sugars, and I want it to group by shelf. Okay, and we'll just compute that, and voila, here we go. Okay. So you've examined these here. I mean, obviously, this middle shelf, this shift all the way up. Okay, and if you look here, right, so if you hover over here, the box plot, it tells you the lower limit, which was 0, the first quartile, which was 2, the median, which is 3 grams, the third quartile is 10 grams, and the upper limit was 15 grams. Okay, so you see the bottom has the kind of a wide range of, well, they all more or less have a wide range of sugar amounts. But if you see here with the middle, okay, this box here is, we can say using Q1 and Q3 that 50% of the sugar amounts were between 7 and 12 grams. All right. All right. Right. And here, what we could say here is that 50% of the sugar amounts for the top shelf were between 3 and 9.5 grams. And here we could say 50% of the typical sugar amount was between 2 and 12 grams. Okay, but obviously here, from this visual here, we can even say, you know, if we take in, this is 50%, this is 25%, using Q1, we could say, well, 75% of the sugar amounts were greater than 7, right? Right. So here it's kind of obvious a winner here. Okay, obvious winner here, that the middle shelf is the shelf with the higher sugar amounts. Okay. So let me show you another example really quickly here. This is the body image data set. So remember, we're also examining the GPAs, right? We're looking at the GPA with respect to where you sit in the classroom. So let's just take a look at that here. So I'm going to do graph, and I'm going to do box plot. I'm going to do GPA, and I'm going to do group by seat. Okay, and then I'm going to compute. Okay, and look at this here. So if you look at these plots, you see for the front row we get one dot out here, right? So StatCrunch was using that 1.5 times the interquartile range rule, and it said that this GPA of 1.92 is weird. Okay, it's way too low considering the GPAs that we found for students that sat in the front row. So we're not gonna include this as the minimum value because we don't feel represented. It doesn't fit in with the data, but let's just think of it as an outlier for now. Okay, so so like the lower limit or the minimum here was 1.96, whereas this was 1.92. Okay, so it wasn't counted as the minimum, it was just counted as an outlier. But where this whisker's at, that is the minimum of this distribution here. Okay, so if we're asking for the minimum, it's not going to be the outlier, it's going to be where this point is here. Okay, so in this example here, I mean, if we're just looking at the box plot for the front row, it's saying, well, let's see, the first quartile was at 3, so, and then the third quartile is 3.7, right? So this is 3 to 3.7. So it's saying 50% of the GPAs are between 3 and 3.7, right? And then I think the maximum up here, the upper limit was 4. Okay, so I guess they're getting high GPAs here, but oh yeah, I guess the GPAs, there's 4.2s out here and all that. Okay, so the GPA here is a 4.1. Okay, so really, I mean, if we take 25%, 25%, 25% here, 75% of the GPAs are 3 or more, right? 3 or more. All right, so if we were to look here for the back row, right, this is just saying, well, 50% of the GPAs for the back row are going to land between a GPA of 2.67 to 3.25, right? So we get 2.67 to 3.25, right? So I don't know if you recall last time we were doing the empirical rule, and the interval for the back was very, very large. Okay, the interval that we created was very large in comparison to the front and the middle, and the reason is probably because you know, maybe the mean and standard deviation, they weren't the most appropriate here, right? Or it was just harder to visualize, right? But with the box plot, it's pretty straightforward and a little easier to visualize and to compare these distributions here. Okay, all right, but that's all I want to show you for chapter 3, and this concludes chapter 3. So just make sure you're working on StatCrunch with me while you're watching these videos, and of course ask you some questions on the year up. Okay, but this concludes the material on chapter 3. When I see you next time, we'll be talking about chapter 4. All right, bye bye.